It's space weather! Got the sun on 304 angstroms. See some big-time plasma filaments on the northeast and on the southeast. Otherwise, activity levels super weak. No sunspots. Some small, diffuse southern coronal holes. And a solar flux that has now dipped below 70 once again. Head to spaceweathernews.com. See the X-ray flux is still flatlined. Solar wind speed and density are anybody's guess, as well as the phi angle. Missing data galore. Looks like there's been an uptick in the density. So we're expecting a small, weak coronal hole wind stream to come in at any moment. Here's the magnetometer spike that we predicted yesterday. It made it to about, what's that, 130 nanotesla. And now you're seeing a little bit of interference going on here, as there are some jumbled up magnetic fields in the area just before the void in the heliospheric current sheet. KP index up to 2. Here's your Cygnets forecast, which is through the 17th, I think. Through the 16th. Let that play through. See, the electron flux is starting to dip now, and that's typically associated with coronal hole wind streams. Don't be surprised if this bottoms out shortly. Charging hazards are pretty much non-existent, and the F2 layer is looking pretty normal right now. There are your aurora forecasts. Nothing major going on there. Earthquakes are steady. Let's look at the last 15 hours. 4.4 in Mexico. 4.4 in Alaska at Tanaga Volcano. Let's take a look at that one. Out at the end of the Aleutians. .7 in Indonesia, 5.0 in Tonga, 5.0 in Alaska. That's on the North Shore area. And a 4.7 in the Solomon Islands at depth. 4.6 in Indonesia, 5.1 in Japan, which I think we alerted for yesterday due to a deep quake there. 4.6 in Russia. No other quakes to note. Check out the volcano situation at volcanodiscovery.com. Today's volcanoes include Shivaluch, with a continuing ash cloud of 18,000 feet. Fuego, 14,000 foot volcanic ash cloud. Revenador, intermittent clouds to 17,000 feet. Sabancaya, intermittent puffs of volcanic ash. Planchon Pitaroa, volcanic ash not identifiable from satellite data. Also, we've had an earthquake swarm in Santorini. Possibly signaling some kind of an uptick in magma movement around that area. Well, that's something to keep an eye on. 16 quakes between magnitude of 2 and 3.9 have been detected. Also, I wanted to draw your attention to Anak Krakatau, as It has created some new land. Check it out. Look at all that dirt in the water. Here's the old caldera. Here's a bunch of venting that's still going on. And the new caldera is anybody's guess, possibly underwater now. Crazy, crazy stuff. There's the crater lake. Entire island is covered with volcanic ash. And that video is unavailable. Okay, well, in any case, there's an image of it. And here's the Gong 2 data, as we were looking at yesterday and the day before. You see this area here, where the magnetic field lines are a little straighter. More of a direct connection to the corona there. That's what is the cause of the current magnetometer spike we see on the GOES magnetometer. Also, beware that there's going to be a new heliospheric current sheet crossing when Earth's magnetic field snaps across this. So that's going to cause some perturbations, and we'll be taking a look at it in as real a time as we can. Here's the animation. And so the magnetometer spike is caused by that. We're going to see some weakness, and then we're going to see a sudden crossing of that current sheet again. I'll give that 2 days. But as our regular viewers know, the magnetic situation can change instantaneously with absolutely no warning. By the way, this data is 2 hours and 4 minutes old. Taking a look at the magnetosphere movies here. Here's the velocity. Going to see this drop off at the end due to a weak solar wind. Here's the density. It's going to look quite a bit like yesterday, as the density drops off a cliff. But at the end of the video, and there you go with that low solar wind speed. Solar wind density, rather. And finally, you'll see the pressure drop off a cliff as well, corroborating the rest of the data. Let that play through. There goes the pressure. Didn't drop as low as it did yesterday, and it looks like it's starting to return. We do see some magnetic perturbations on the ground, according to University of Michigan's model. Right at the end of this, you will see what amounts to a global magnetic pulse. There you go. It spreads basically across both poles there. Let's look at it from the global view. right in this area. See the South and the North Pole essentially magnetically connect right there. Next, look at planetstoday.com. Check out your planetary locations. If you're up before it's light out and you got clear skies, you should be able to see Venus and Saturn. Venus, the third brightest object visible in the sky after only the sun and moon. If you see it in the early morning, you should be able to also see Saturn slightly lower and to its left. Here's where the planets will be in 7 days. Earth will be approaching a Mercury opposition. Moving on. And let's give a plug to inthesky.org. They've got a great sky map. We'll leave links to it and everything else we visit. Highly recommended. Before we look at some even weirder stuff, let's look at the constellations. Where will you be when Cygnus rises? So, if you head to this site, put in your town, it's going to show you what constellations and stars and planets, and you can even animate it like so. Here you can see actually Jupiter, Saturn, and Venus and Mercury all rising early this morning. Now let's get into some really weird stuff. The scaled map transient analysis for Cygnus X3. Well, what the hell is that, you ask? Well, we track transient events on a burst alert telescope, doing some radio astronomy here, looking at one of the odder objects in the Milky Way, located about 1,500 light years from Earth. This crazy X-ray binary is a very reliable radio source, and the massive X-ray source appears to be orbiting on an orbit about the size of Jupiter's orbit every 4.83 hours. So if that's not a weird object, I don't know what is. Here's the transient analysis. By the way, the highest output we've seen from it is right around 2009. And yes, this is indeed a cosmic ray source as well as a radio source. If you'd like to look these weird objects up yourself, they're being monitored constantly by the Burst Alert Telescope. We will leave links to this, as this is a crazy sight. Hundreds and hundreds and hundreds and hundreds of radio sources. Everything from pulsars to clusters to X-ray binaries, quasars, the Crab Nebula, pretty much everything in the universe that's sending significant radio signals. So let's look at a couple more here. What do we got here? Here's Cygnus X1. This is the massive radio source that Stephen Hawking and Carl Sagan famously had a bet about whether or not it's a black hole. We're not going to cover that. We'll just say it's a massive radio source. There are the transients from Cygnus X1. And actually, it looks like it celebrated the new year here. It must like 2019 because it's moved into a higher output mode. Next we've got, this is Cygnus A, which is a massive active galactic nucleus. In other words, another galaxy. Cygnus A, another quite weird object. This is one of the strongest radio sources in the entire universe. Discovered by Grote Reber in 1939. Here's what it looks like. That is in radio frequency, I imagine. Let's see these columnar jets coming out. And your massive radio source located in the center. Cygnus A. We will leave links. And lastly, let's look at Sagittarius A star. Regular viewers are aware that this is the core of the Milky Way galaxy, the massive radio source in the constellation Sagittarius. And there's the transient analysis of Sagittarius A star. It looks like it's celebrating the new year too, because it was in a state of low activity. Transient, passing with time, or transitory, remaining in a place only a brief time, or in physics decaying with time, especially as a simple exponential function of time. Transient analysis. And indeed our analysis is transient as well as time sensitive, which is why we put these out at 4 o'clock in the morning. Finally checking out 171 angstroms. You can see the filamentary activity expressed up here in magnetic looping. Let's close up. Hey, thanks for watching, everybody. We're nearly at 800 subscribers. If you've got ideas for an 800 subscriber special, please let us know in the comments. Please don't forget to like and subscribe if you enjoy the content. And remember, when you're staring at the sun in 171 angstroms, don't drink. And if you drink, stare at the sun anyway. Use the SDO. It's fun. And don't drive.